and we will be learning about the various methods used for the same. The first concept that we need to get cleared is what is carbon sequestration. Carbon sequestration refers to the capture and storage of carbon dioxide from the atmosphere. Carbon sequestration has mainly three steps: capturing carbon, transporting it, and final sequestration. Carbon capture is referred to the capture of carbon from the atmosphere. The easiest way to do it is from the exhaust gases that are released from natural gas power plants, coal-based power plants, or various industries such as cement, steel, etc. Capturing carbon can be done in one of the following three ways. It can be either done before the combustion of carbon-rich fuel, after its combustion, or using a third method called oxy-combustion. Pre-combustion capture involves capturing carbon dioxide before its combustion. The fuel that is generated is a hydrogen-based clean fuel. For pre-combustion capture, there are mainly two processes. The first process, called IRCC, or Integrated Reformed Combined Cycle. In this, the heavy hydrocarbons in a natural gas are first converted into carbon dioxide and hydrogen. Later, the natural gas itself is converted to carbon dioxide, carbon monoxide, and hydrogen. This mixture is called the syngas. Whatever carbon monoxide is present in the syngas is then converted to carbon dioxide. This is then collected and liquefied for ease of storage. As seen, the air separator unit separates out oxygen, which is fed into the gasifier, where the fuel burns and syngas is produced. This syngas is then separated out for carbon dioxide, and the hydrogen from natural gas is called as blue hydrogen. In the second method, that is IGCC, or Integrated Gasification Combined Cycle, is a cost-effective method employed in coal-based power plants. This is a very cost-effective process because it can be retrofitted to existing power plants. In this method, coal is decarbonized and then used to generate electricity, thereby purifying the coal and providing better thermodynamic efficiency. In this method, the coal is first treated with oxygen under high pressure. It is done by creating a slurry after mixing it with water. This is then passed through the cooling section, and the water gas shift reactors convert the coal into hydrogen and carbon dioxide. This carbon dioxide is then removed and liquefied under high pressure and stored, and the fuel that is produced is called as black or brown hydrogen, which is a cleaner alternative to normal pulverized coal power plants. Post-combustion capture process involves capturing carbon dioxide after the fuel is burnt. The exhaust gases emitted by the industries are captured, and then carbon dioxide is separated out. This carbon dioxide is then liquefied and then stored. The third method, called oxy-combustion, is a type of pre-combustion capture where instead of normal air, pure oxygen is used. It is a rather cheaper alternative to pre-combustion capture, since the cost of separating out oxygen from normal air is quite high. Hence, this can be called as a better type of pre-combustion capture. The next step is transportation. Transportation of carbon dioxide can be done easily using pipelines. Since we already have experience in transporting natural gas using pipelines, transporting carbon dioxide does not prove any additional hazards. Small quantities of carbon dioxide also can be transported using ships. The final step is called sequestration or storage. It facilitates the storage of carbon dioxide in carbon sinks. It can be done via biotic or abiotic means. Biotic sequestration, which refers to natural sequestration, can be done by oceanic or terrestrial ways. Oceanic sequestration involves sequestration of carbon dioxide by phytoplankton. They use carbon dioxide for photosynthesis and then they get deposited on the ocean bed. This method aims to sequester around 45 gigatons of carbon dioxide per year. Terrestrial sequestration is a method of sequestering carbon via terrestrial plants. As they use carbon dioxide for photosynthesis, this way they capture carbon dioxide and store it. However, since our carbon dioxide emissions have been skyrocketing, the need for abiotic sequestration means has risen manifold. Abiotic sequestration involves ocean injection, where carbon dioxide is injected at depths greater than 1000 meters, where carbon dioxide exists in the form of droplets. Another method is geological sequestration, where it can be stored in exhausted hydrocarbon reserves or deep saline aquifers. Mineral carbonation is a process in which carbon dioxide is stored in the form of carbonates as rocks. Carbon dioxide can also be used as enhanced recovery projects, as enhanced oil recovery projects, enhanced gas recovery projects, where carbon dioxide is injected and it displaces the oil or natural gas, hence we recover methane, which can be used as fuel and also sequester carbon. India's GDP rate increased to 6.375 from 1991 to 2019. However, this increase came at the cost of quadrupling CO2 emissions from 779 megatons in 1994 to 3.6 gigatons in 2019. The power sector contributed to around 50% of these emissions. However, India has taken many steps to employ CCS technologies in its power plants. It has taken many efforts and invested a lot in sequestering carbon in many enhanced recovery projects. There has been a lot of investment done by the nation to curb its CO2 emissions too. The maximum capacity of sequestration held by the country stands at around 1000 gigatons, which includes many sedimentary basins scattered across the country. Deep saline aquifers and Deccan Trap basaltic rocks also serve as a suitable location for sequestering carbon dioxide. Apart from them, unminable coal seams and depleted hydrocarbon reserves can also be used. I hope you find this video insightful and hope it has made you aware about this upcoming topic of CCS, which can help us reduce our greenhouse gas emissions. If you have any doubts or suggestions, feel free to contact me at the email provided, and I will surely reply as soon as possible. Thank you.